plus 303. They are like terms, are they not? Yeah, because they are just numbers. I can add them. Then they will give me 304. But then if I have got x plus 303, I'm talking a different story now, because I have got an x and this 303 does not have an x. That fact alone, variable one side and the variable on the other side, it means that those terms are not like terms. Okay? Yes. And then therefore my solution will be x plus 303, because unlike terms, these ones are considered as unlike terms, because I have a variable this side, I don't have a variable that side. Therefore, I cannot add them. I just leave them as they are. Okay. So now I am going to say, let's say for example, I have got x plus 303x. How did I get this 303x? I multiplied the 303 with the x. Okay. So now I have got an x this side and I have got an x on the other side. Therefore, this tells me that these two are like terms. Therefore, I can add them. And with like terms, what are we adding? We are adding the coefficients. Remember, the coefficients are the coefficient of a variable are the numbers that multiplies a variable or that divide a variable. Okay, so in this case I have got x and the coefficient of x will be 1. Why does it have to be 1? Because when I multiply 1 with x, it gives me 1x, which is the same as x. So I'm going to add 1 with 303 and then I just keep the x. Then I have 304x. 304x. Does that make sense? And let me give you a simple number. Again, I've got 2x plus 5x. What am I adding? I'm adding 2 and the 5. I'm adding the coefficients of those variables. That is going to be 7x. Okay? These are like terms. So sometimes you can have 2x plus 5x squared. Okay, and I have an x here and then I have got another x there. But are they really like terms? No, I cannot consider them as like terms because the exponents are not the same. The exponent here is 1 and the exponent there is 3. The fact that those exponents are different, it makes them unlike terms. Therefore, they cannot add. Their coefficients cannot add. So I'm just going to leave it as 2x plus 5x squared. I hope that makes sense, boys and girls, because that is all about differentiating between like terms and unlike terms. Okay, so now let us see how do we get to have like terms and unlike terms. This is where we are going to simplify. Okay, I have got the first one. I've got 3 multiplied by a plus 5 multiplied by b. I'm going to take you back to the simplest word that we normally use, or acronym, which is BODMAS. BODMAS, meaning that I have to follow the order of these, whereby bracket of division, multiplication, addition, and subtraction. It means that before I multiply, I must divide. And in this case, we have got multiplication, we have got addition, and we have got multiplication. So it means we have to honor BODMAS. It means multiplication first and then addition later. We have to honor it. So it means now I'm going to multiply first. I'm multiplying the 2. And then I'll think of addition a little bit later when I'm done with multiplication, okay? So that will be 3a. 3 multiplied by a is 3a. Plus 5 multiplied by b is 5b. And now I am continuing. The second question that I will have to ask myself is, are they like terms? Can I add them further? And now I'm checking the variables. I have got a here and I have got b there. Are they like? No, because their variables are different, and therefore my solution will be exactly that, 3a plus 5b. You don't really have to rewrite this, you can just leave it as that because that is your solution. I hope that makes sense. Let us go to the next one. I have got 8 multiplication, I'm checking my signs, multiplication, subtraction, and multiplication. And I'm going to my BODMAS. Between multiplication and subtraction, which one comes first? Multiplication first, right? So it means whatever that I do, I have to multiply before I can subtract. Let's do that. 8 multiplied by 3x, it's going to give me 8, 16, 24. Yeah, I think it's 24. 24x minus x multiplied by y. It will just be x, y. Okay? Now, before I can leave it, I have to ask myself, do I have like terms? Are they like terms? I have x this side, I have x, y that side. The fact that I don't have y on that side and I have y on the other side, it makes them unlike terms. Therefore, they cannot do anything with each other. They cannot subtract, they cannot add. Okay, we leave it there. That is my final solution. And now let us go to the next one. I have got 2 multiplied by x minus 2 multiplied by 3. Still checking my signs first. I've got multiplication here, subtraction, and multiplication. Which one comes first? Multiplication. So 2 multiplied by x, it gives me 2x. Minus 2 multiplied by 3, it gives me 6. Now, before I leave it, I'm asking myself, are they like terms? How do I know if whether they're like terms? I'm checking the variables. Do I have the same variable this side and that side? No. This side I have got an x. This side I don't have an x. Therefore, they are not like terms. I hope that makes sense to you. So, this will just be my solution and I'm going to leave it at that. We are doing the last one. I hope by now you are understanding what we are doing. Now I have got 3 multiplied by x multiplied by x plus 4 multiplied by x minus 2 multiplied by x multiplied by x. I have to honor BODMAS. So which one am I starting with? Multiplication. Yay! So I've got 3 multiplied by x multiplied by x. So here we are going to consider laws of exponents. If you can think back, when powers of the same base multiply, their exponents add. So when I have got x multiplying x, I've got little exponents there which are 1, are invisible. We prefer not to write them because they don't change the value in any case. So when I multiply x and x, it will give me x, the exponents will add. I keep 1x and I'll say 1 plus 1. Then I'll have x squared. That's why I'm saying here we have got 3x squared. I hope it makes sense. It's just the knowledge of exponents there. Plus 4 multiplied by x, it's 4x. Minus 2 multiplied by x multiplied by x. Remember, when x's multiply or when variables multiply, you think of their exponents, you add their exponents, particularly when the variables are the same. So x times x is x squared. So it's going to be 2x squared. Now we are here. This is our second step. We are going to check, do we have like terms? If we have like terms, can we group them? Yes, we can group them. Do we have like terms? Yes, we have like terms. I have got x here with exponent 2. I also have x with exponent 2. This one is not the same as those ones. So these 2 are the only ones that I like. And this one is different to them. So the next step here, I will be grouping like terms. And when I group like terms, I literally mean just move them closer. Just so that it will be easy to work with. So I'm going to have 3x squared. My 2x has got a sign there. So I'm moving it closer to the 3x squared with its sign. 2x squared. What I have just done here, boys and girls, is grouping of like terms. Just put them closer just so that it can be easy for you to see them. And then my 4 has got a positive sign there, 4x. I'm just going to rewrite it up here. I'm going to 1, 2, 3. This is my 4th step. But really, these steps are not necessary. But then for your sake, because you are still a novice, you have to do them. You're still a learner. You have to do them. So it's going to be 3x squared minus 2x squared plus 4x. So now I have like terms. And these two like terms are subtracting. What am I subtracting? I'm not subtracting the exponents, I'm not subtracting the variables, I'm subtracting the coefficients of the variables. So basically I'm focused where? On the numbers. 3 will subtract 2. And when 3 subtract 2, I have 1. And because I'm dealing with the x squared, I just take it along. How easy is that? Plus 4x. 1x squared is the same as x squared plus 4x. And you are done. That's all about today's lesson. I hope that when we meet, you will be having a better understanding. And should you not have any understanding, I will post this on my YouTube channel and then you just comment with questions, baby. I'm gonna get back at ya.